Alright, so today we are actually going to have two tutorials. They're kind of on different subjects and radically different. The first one is going to be a little bit more statistically complex than the second, although ultimately, for the first one, we are going to calculate regression. And regression is probably the single most fundamental tool for statistical analysis for basically every research area. Today we're just going to use linear regression, but as you will see as the course goes on, there's a lot of different ways to look at regression in addition to linear. Within R, there's a really great data set that is often used to illustrate linear regression, and it's the Swiss data set. There's a bunch of different variables in the Swiss data. Let's see what those are by typing $Swiss and then hit enter. And we see that it's a standardized fertility measure, socioeconomic indicators from 1888, thereabouts. It's a pretty famous data set. You'll see it used a lot. But we are going to make a hypothesis that the more education someone has, so the higher education level, the lower the fertility rate. You know, we see this in the US right now. The higher the education level, the lower the fertility rates are, and we want to know if the same was true in 1888. So we are going to get started by loading the tidyverse library. We actually, I think, don't need it for this, but it's almost like by default that I pull in the tidyverse library. And the next thing that we're going to do is set our data equal to the Swiss data set. Now, if we were using something like ggplot, we wouldn't need to do this, but I need to explicitly tell R that I'm going to use a data set, and the data set's going to be the Swiss data set, because I want to be able to transport it around really flexibly throughout my little program here. Okay. And then I'm going to say I just want the most basic plot possible. I don't want anything fancy. I don't want to customize it. I just want to see what's in my data. So I'm going to use the built-in plotting tool that comes built into R. So you can't customize this. You can't make it pretty. We'll make the next graph pretty, I promise. But for right now, we're just going to type plot, and then we're going to pass it. We're going to say, hey, I want to use a Swiss data set, and I'm going to select one of the columns from the Swiss data set. And the way that you select a column from a data frame is with the $sign. So I'm going to say I want fertility, and I want to see how it's related to education. So I'm going to type here a tilde. The tilde syntax in R says that it is the next variable is going to be independent. So when you're taking the shortcut and just making the most basic plot, we're basically saying dependent, independent. So I'll go ahead and call in the Swiss education data. And if I run that, I get a nice little scatter plot. And my scatter plot is already suggesting that my hypothesis might be correct. You know, you see how much education there is, and you see these lower numbers over here. You see the fertility rate really high over here with very low education numbers. Now, quick sidetrack on dependent and independent variables. This format of writing, hey, just give me the most basic plot, builds in the very idea that fertility is predicted by education. So now we want to know just how much does education affect fertility. So we are going to ask for the regression line. We're going to say reg, I'm just specifying my variable, is equal to lm which stands for linear model. I'm not asking for anything logarithmic. I'm not asking for any kind of complicated format here. What I want is that mx plus b, your slope and your intercept. Because what we're trying to calculate is the linear relationship between fertility and education. A lot of times there won't necessarily be a linear relationship, but we're going to see to what extent there is a linear relationship here. All right, so I've set my variable, I've set it equal to a linear model, and I've used the newer equals version. You'll learn about this in the next lecture. And I'm going to say fertility as related to, or as predicted by, education. And I'll use the Swiss data set. This is just kind of a shorthand to say these two columns from this data set. So I want to see the relationship between fertility and education in the Swiss data set. You can't do this if they're in different data sets, but almost always you have your two columns in the same data set. All right, so I'll hit enter, I'll run that, and we will call our regression in order to see what we got. Excellent. And here we have our coefficients. So we see that there is, in fact, a linear relationship between education and fertility, and it's a negative relationship. So the more education, the lower the fertility. And what this intercept is telling us is that for a province that has 0 education, we would theoretically predict a fertility rate of 79.6. And that is a hypothetical. It's obviously, there's going to be very few provinces with 0 education, but this really tells us what our starting place is. And we can kind of see that over here. 76 would be about here, which means that our line looks something like that. But it'd be really useful if we could actually see our line. So let's go ahead and put a quick line into our very quick plot. So we will go ahead and type here AB line, and then we're going to pass it the regression. So I've just said that I want you to give me an AB line from this regression that I specified up here, that I already set my variable for. So we type AB line regression, and it gives us the linear regression line that represents our data set. And this is really powerful because it gives us a visual representation of the two-dimensional average of our data set. So we have here our formula, our y equals mx plus b type of formula that gives us the linear equation that creates this line. But this allows us to really see that the linear average of our data points goes through this space. And it seems like this province, whatever this province is right on the line. They are exactly the average of this data set. All right, so that is it for linear regressions. This was pretty basic. We will do more with linear regressions and with building these lines as the semester goes on. But for today, it was really just to illustrate that the quote-unquote average of the data set is well represented by this visual line, by this AB line that goes through your scatter plot. All right, please move on to the next lecture where you'll learn some of the things that we skipped over in this one. All right, take care.